In this video, I will present a platform for visualizing geotemporal crowding data. This platform is being developed as part of the Resetting project, which aims to improve the quality of the tourism experience. Our platform can be used to explore historical crowding data and understand trends, or to view near real-time data, which can help in short-term decision-making. The platform has an extensible, connector-based architecture and is able to fetch data from several types of data sources, such as databases, APIs, and queuing systems. So far, we have configured 3 instances of this platform, one for the city of Lisbon, based on data provided by LX Data Lab, another for the Iscte campus, using Wi-Fi sensors, and another for the city of Melbourne, using public data used for the city's pedestrian counting system. I will begin by presenting the features of the application, and afterwards I will show you a few use cases so that you can see our application in action. If you are interested in this platform, please reach out to us. In the application, we can see a map of Lisbon divided in a grid of squares that are 200 by 200 meters in size. Now I will enable the data layer of the application, and we can see cylinders superimposed on the map. The cylinder's height represents the number of detected devices at a particular time in a given location. And as I hover these cylinders, we can see the number of detected devices. At the top, there is a slider that indicates the current time and date that we are visualizing, and we can drag through the slider to select which moment in time we want to visualize on the map. We can see the cylinders instantly augmenting or shrinking according to the values. The map is interactive. We can pan, we can change the pitch, we can rotate the map, and we can zoom in and out. These interactivity features are very important in order to help the understandability of the visualization. As we zoom in and out, the size of the cylinders relative to the map adjusts automatically. This is so that when we are very zoomed in, high values can still fit the viewport, and when we're very zoomed out, we can distinguish fine differences in values. Now I will show you some of the visualization options. The dataset that you are visualizing contains various types of metrics. Right now we are visualizing the C1 metric, which corresponds to the total number of distinct devices that were detected in each square. But we might also be interested in the C2 metric, for instance, which is the number of devices that are in roaming. So this metric may be more relevant for tourism, since tourists are more likely to be using roaming in their devices. Now I will put the metric back to C1, and I will show you that you can map another metric to the hue of the cylinder. So if I do this, the cylinders now have a color that correspond to the value of the number of devices that are in roaming. And as we hover through the cylinders, both values are displayed. So we can see here that in this area uh, next to Rocio, there is a high concentration of possibly tourists. We can also choose the hue to represent the density instead of a different metric. So now the hue corresponds to the number of devices per hectare. This is not just a unit conversion. We are not dividing, in this case, 2,637 devices by the total area of the square. We are dividing by the walkable area of the square. That is, from the total area, we subtract the area of buildings, roads, bodies of water, if any, so that in the end, our density metric is more relevant to understanding how crowded a place really is. The slider serves a purpose beyond just selecting a moment in time to be visualized. You can notice that the background of the slider is a color gradient from green to red, which represents the sum of values for the whole map. We also have another timeline visualization, which is a line chart. All of the moments that are selectable through the slider are represented as points here. So the horizontal axis represents time and the vertical axis represents the total number of devices that have been detected in the entire map of Lisbon. So as I hover these points, you can see that it is displayed the date and time of the point as well as the total number of devices that have been detected. We can also choose to view the values in density form, again as devices per hectare, instead of in absolute form. Now I will go back to absolute, and I want to show you that if we select a metric in the hue component of the cylinders, the line chart becomes a dual axis line chart, where on the right we have a scale for the C2 metric, and instead of having one line, we have two lines. One of them represents the C1 metric and the other one represents the C2 metric. Now I'll go back to density and I will show you some other features that can be interesting. For instance, we can play an animation. Doing this makes it so that the slider keeps moving forward at a fixed interval. We can use the fast forward and fast backward buttons in order to seek through the local maximum and local minima. And a very important feature is the ability to draw an area of interest. That is, I can draw a polygon on the map. So now I will draw a triangle, and these squares become selected. So what this does is that the values in the line chart are relative to the selected squares and not to the whole map. The slider colors now also represent values for only the selected squares. We can also select squares by clicking on them to select them, or if they're selected, we can click on them again to deselect them. We can, if we want to, hide the cylinders that of the squares that are not selected, or we can even choose to not show any cylinders. This can be useful if we want to understand what there is on the map, and if the cylinders are obstructing the view, we can just hide them. So we have loaded data from June 10th, 2022 at midnight to June 14th, 2022 at midnight. So this range of time includes the popular saints festivities, which are yearly festivities that occur in Lisbon, during which streets become very, very crowded, as we can see in these pictures. So Saint Anthony's Day is at day 13, and so we could expect the higher levels of crowding to occur in the night from 12 to 13. However, as we look at the line chart, we can see that the most uh, the highest value of detected devices in all of Lisbon was actually uh, in the night from day 9 to day 10, which is something we were not expecting. And this is something that a visualization tool can help us with, which is finding things that we were not expecting in the data. Now, one of the questions we might have is during this weekend, which was the moment in time that had the highest number of detected devices? And we can see through the line chart, if we ignore this uh, time, the highest value occurred on day 12 at 11 p.m. And now we can make another question, which is given the select time, which areas were the most heavily crowded? And we can see here that all of this region is pretty crowded. We see a lot of yellow in here, but clearly the biggest ones are around here in Graça. We can see in here in this area specifically that the density reaches 1,000 devices per hectare. And now we can make another question, which is given a location, which times had the highest level of crowding? So now I will draw an area of interest. I want to understand better what is happening here around Graças. So I will just draw a rectangle that will include all of these squares. And something interesting happens. We see that actually the most crowded moment for this particular area is not at 11 p.m., but at 3 a.m. So now I will stick to this and we can see that indeed there is a lot of red, a lot of very tall cylinders which hit the limit. And now this square that had 1,000 devices per hectare now has more than double, which is interesting. Uh, our visualization doesn't show that directly through the color because it is very much past the limit that we have defined in the application. So we are talking about levels of crowding that are far, far beyond what is normal. So now I will show you very briefly a few other uh, interesting situations that deal with crowding in Lisbon. So the first one, let me deselect this region. The first one is Rock in Rio, which is days 18 and 19 and then 25 and 26. So I will use this range from day 17 to day 28 to include the 2 weekends so that you can visualize and compare them at the same time. However, it will take a very long time to fetch the data for all Lisbons. So I will select the parish that includes the location of Rock in Rio. In this way, we are only loading data for the relevant parish. So now the data has loaded and we don't see anything because we have only loaded data for Marvila and here it is. So Rock in Rio happens at Parque de Bela Vista, so I will draw a polygon surrounding the area that we want to see, which is something like this. So we can clearly see in the line chart the peaks of the levels of crowding. So around day, so here we have first day of the festival and then the second day, and then we can see that the second weekend was much busier, so much that the first weekend does not even show on the sliders color gradient. So here we see again we have just like in Santos Populares we have such a big number, we have such high density values that it reaches the limit and it doesn't show just how much crowded some of these red squares are comparing to others. So now I will very quickly show you Nos Alive, which is also a festival for which there is a lot of crowding. It happens at Algiers, which is not part of the locations in our dataset, but there is still a piece of Belém that intersects with the location of the festival. So it happens from 6th of July to 9th of July. And now just to show you another feature, we can choose a different type of interval. This defines how the data will be aggregated and averaged. Let's say instead of 1 hour, let's say 30 minutes. And now we can load. So the festival happens at Passeio Marítimo de Algés, which is around this area. So we can see areas that are pretty crowded around here. The festival will happen around here at Passeio Marítimo de Algés. But you can see there is still evidence of heavy crowding in this area. So now I will show you another instance of the application, that is the application to show crowding in the Iscte campus, which can get pretty crowded during exams, for instance. You'll notice that there is a new button here that was not available in the Lisbon instance of the application, which is a live button. When we press it, we load live data. Right now it's 20:36 and we are seeing data from 20 hours and 35 minutes. We load not only the most recent instance, but also a few minutes before that, so that we can make use of the temporal dimension of our visualizations. And as you can see, the bars are very, very tiny. So the exams have ended, uh, students are ready to go on vacation. So the Iscte campus is uh, not very crowded at all, as you can see in this the corridor behind the bar, which is the place where usually there is the highest level of crowding. Right now is, well, pretty empty. 24 devices detected is not many at all. So now I will speed up the video and we will see new data arriving as time passes. A new batch of data arrived to the application. We can see now that the most recent moment was at 2039. We can see in the line chart that we have less devices being detected by our sensors. So just to finalize this video, I want to show you the Melbourne instance of the application, which is based on the Melbourne's pedestrian counting system, which has a public API that our application fetches. So right now we are viewing the map of the city of Melbourne, and you can see from the line graph that we have already fetched the data that we want to see. So now we have cylinders placed on top of the location of each sensor for which we have a reading. And so this is historical data. We also have the ability to view live data as it is provided by the city of Melbourne. So for instance, on day 7, this was this Friday at 7 p.m. We can see here, for instance, in this sensor, we have 1,424 pedestrians, and this is the official application of that uses this data, and we can see at this is the same location around just behind this bridge over here. So they call it the art center, and as you can see, 1,424 pedestrians at Friday 7 p.m. So this is just a way to validate that we are fetching the correct data.